It says a real sailboat and a model sailboat are shown. What should the length of the model sailboat be? Explain your reasoning. So what do you guys get? Yep, go ahead.
3 feet because it's a model, so therefore a replica with exact proportions, and it's a third the height of the original.
Yep, perfect. Yeah, so if you guys look at the relationship they gave you right here, the 12 and the 4, the scale is a third, right? So then you want to just keep that scale constant for this side. Make sense? Cool. All right, so we are doing proportions today. Your objective is students will be able to solve and apply proportions. So we're going to start with like the basic ones that hopefully you've seen before. If you haven't, that's okay. We're going to just review it. Then we're going to move on to some ones that are a little bit more complicated that have like distributive property in them. And then we're going to do word problems and like setting up proportions for them. Okay? That's where that like apply comes in. All right, so first, what a proportion actually is. So, grab this. Okay, so a proportion is an equation, so it has an equal sign in between, and it states that two ratios are equal. And then ratios, remember, those are just fractions. No, we just synonymous with fractions at this point. And then we solve them with the cross products property. So what that property is that it says that if you multiply the two diagonals together, they're going to be the same. Okay, so this diagonal is going to equal the same as this when you multiply them together. Okay? So when we start on this first one, you're going to multiply the diagonals together and then put an equal sign between them. I like to start with whatever diagonal has the variable. So you're going to multiply these two together. So you're going to do 8 times m. And then multiply this diagonal together to get 7 times 12, or 12 times 7, doesn't matter. So you guys might want a calculator for like stuff like this today. All right, so 8 times m, you'll just keep it 8m, and then figure out what 7 times 12 is. Good. And then you're just going to solve this just like all of the other equations that we've been solving. So the only real new thing today is taking the proportion and just setting up the equation from it. Okay? Everything else is going to be the same as we've done. So how did I finish solving this one? Yeah, divide by 8. And remember, we want exact answers. So if you want to divide that, you can. But if you get like a repeating decimal or something, then you want to just keep it as a fraction. So is this one like clean when you divide it? Does it like just stop at the decimal, or are you going to round? So what would you guys get? 10.5. So that one would be fine to do a decimal if you wanted. Because it like 10.5 exactly. If it was like 10.3 repeating, where you have to like cut it off at a certain point and like change it, that's when you don't want to do it. Okay? But pay attention, because Math Excel will tell you like keep it as a fraction, or it'll say type in decimal or an integer or whatever. Okay. All right, you guys try that next one. So multiply the diagonals together and put an equal sign between them. Yeah, I think that one divides columns. I didn't divide it, but you need like that to do this one. Yeah, it's over 5, so it's about. Okay, do you want to do it first? So on this one, so your first diagonal, 5 times x, and then 7 times 4. All right, so you'll get 5x equals what? 28, yep. And then how would I finish that one? Divide by 5. Okay, so it's really up to you on this one, because this one does have a decimal that like cuts off. It's like a clean decimal. So you could do that, or you could just leave it as 28 over 5. I'm fine with that too. Okay. I think the decimal is like 5.6. Is that right?
Yeah.
Okay. Or you just leave it as a fraction. Okay. Good so far. Okay. A couple more that are like more basic like this, and then we're gonna bump it up a little bit. All right, so the next one, the same deal. I'm still going to do the one with the x first. Bless you. So you're going to do 4 times x equals, and then 3 times 8. That's going to be 4x equals 24. And then what would I do? Yeah, divide by 4, so what does x equal? And if you want, guys, if you're not totally sure if you got the answer right, plug it in. So put the 6 in there. Bless you. You can do 8 divided by 6 in the calculator, look at that decimal. 4 divided by 3 in the calculator, look at that decimal, and see if they're the same. Okay? Are you ready to do this next one? Yeah.
I feel like I have problems where you don't use calculator, right?
You can use this calculator for whatever you want.
That's the next thing about not being in middle school now.
This one, I think you leave it as a fraction. Because it's over 3. So try, guys. If I were you, I would be practicing with an actual calculator, not your phone calculator, because on the test, you're going to have to use an actual calculator. So you want to practice on what you're going to use. All right, so on this one, you should do 3 times b equals 5 times 13. So you get 3b equals, what's that, 65? Okay, and then what? So that one is a repeating decimal, right? So just leave it at 65 over 3. No mixed numbers, no. Just keep it. Okay, any questions? Yeah. You can, we just don't ever. Because like later, whenever we start to plug then these into other things, the 21 and 2/3 like doesn't go with anything. Like you just have to convert it right back to that to try to combine it with anything anyway, so we just never do that. Yeah, no, you're good. Yeah. Okay, so now we're gonna take it up a little notch, okay? So here on these ones, you're gonna have more than one thing in a corner. So all that's gonna do is change it to where when you're multiplying, you end up doing the distributive property, okay? And then it doesn't matter which one you do first. So I guess I'll just do this one first. So this is how you're gonna set it up. So the 4 is being multiplied to the b minus 8. So do 4 parentheses b minus 8. So set it up like distributive property. And then for the other diagonal, same thing. 5 is being multiplied to the b plus 3. Make sense? And then, so that's literally the only new thing that we're doing today, guys. That's it. From there to there. That's all that's new. You had a question just like this on your last quiz. You should know how to do this part, right? So distribute on the left. So it's 4 times b. 4b. 4 times negative 8.
32.
Which kind? Negative 32, yeah. Okay, 5 times b. 5b. 5 times 3. 15, yep. And then remember, as from here, you're going to look for like terms, but on the sides separately. So I look just on the left. Do I have like terms on the left? No. Do I have like terms on the right? No. So now you're going to start doing the opposites, okay? So I'm going to move this b over. So how do I move the b? Minus 5b. This will be negative 1b. Okay, and then what? 32. Negative 1b equals 47. Okay, and then am I done? No. Divide by what? Yeah, good. Divide by negative 1. So b equals negative 47. It's kind of hard to see the negative, but that's fine. All right, any questions on that? Okay, take your time getting that down and then move on to the next one once you're good. Mm-hmm.
So like, it might have just been like a passing statement, but you said that it doesn't matter which order that you put that you multiply each side in. Is that correct?
As far as like if you had the 5 times the b plus 3 on the left and then the 4 times the b minus 8 on the right. Yes, but the diagonal should still be multiplying together.
So you have it. If you do 5b if you put 5b on the left, then you get a different answer.
But the 5b, so you would have to still have the 3 paired with it also. So that whole 5b plus 15 would be on the left, and the whole 4b minus 32 would be on the right.
I know. But I'm saying it's the difference between minus 5b to make negative 1b.
Yep, and then minus 4b, yeah. So you'll just have one less step if you set it up that way. Yeah. But you get the same answer, right? Don't erase anything then.
So I guess it's a little hard because I like to do it in my head. It's like a mental challenge. But if you I might actually
So then that you're going to go with 4 minus 5 the overlay, then you're basically doing negative 32 minus 15, okay, which would be
oh wait, no, I did mess up because I forgot to multiply that by 4. Yeah, that's exactly what I did wrong.
Yes. We did 5. We just subtracted. Yep. Subtract 5. That will chunk. We subtracted over to 4b. So make it negative 1. So you'll still distribute the 5 to that one. No, you divide it like, but 5's gonna be in front of it. Yeah, makes sense. So then just 6 then equals that. And then now what do you do? Which one? Oh, okay, good. Over to 6, yeah. Here, for the sake of making it easier, trying to add those together and just multiply. So 5 times 2. So it should be 10n, and then 5 times 4 would be 20. Right. So then that would equal 0. Because you have nothing left there. So you'd have to put that there so that you can subtract the 20 over if you want to do that. Alright guys, let's go over this one. Okay, so for this diagonal, you're just going to have 6 times n. And then for this diagonal, you have 5 being distributed to 2n plus 4. Alright, so you're going to have 6n equals, what's 5 times 2n? 10n, 5 times 4? 20, good. Okay, do I have like terms on this side? What about on this side? No, so then what do I move? Hmm? What'd you try and answer? Good. Minus 10n. So you'll get negative 4n equals 20. And then what? Divided by negative 4. So n equals negative 5. And again, guys, go through and you can check this. So take the negative 5 and put it in for this n. Negative 5 divided by 5 is negative 1. So then put the negative 5 in for that n also and simplify that and make sure you also get negative 1. And then you know it's right. Okay? Yeah. Are you sure?
Yeah.
You sure? Okay. All right. Anything on those kind of proportions with the distributed property and everything that before we move on? Okay. All right. So now we're kind of in that apply part where it's the kind of word problems and stuff like that. So we have these two triangles, and we are trying to find the missing side, and we are going to assume they're proportional. Okay. So something that I need you guys to understand for the rest of this lesson is that, n equals negative 5. That there's going to be multiple ways to set this up correctly. So if you don't set yours up exactly like mine, that does not mean that it's wrong. Okay. There's more ways to set it up right than there is to set it up wrong, which is a good thing. So the way that you're going to check to see if your way is also right is by looking at what the diagonals were, like what's diagonal and getting multiplied together. That should be the same always, okay? So here, when I'm setting up a proportion, if I'm looking at the 10 is allowed to be paired with the x because they have something in common. They're both on the same side of their own triangle, right? The 10 can also be paired with the 16 because they have the same triangle in common. They're on the same one, right? But the 10 cannot be paired with the 12 because they have nothing in common. Does that make sense? So there's two things that you can use to set up the proportion, but there's one that you can't. So what I like to do like this one over this one. You could also do like 10 over 16, but you just want to make sure that whatever you start with the same like corresponding one the second time around. So for example, if I do 10 over x, then I want to do 16 over 12 because I want to start with the same triangle both times, okay? Or if I do like 16 over 10, then I want to start with the 12 because the 12 is what corresponds to the 16 there, okay? So just be careful about the order. So my like instinct is just to do like this over this, this over this. That's what I'm going to do. So I'm going to do 10 over x equals, if I did this 1, 2, and then I'm going to do the same triangle to start with. So 1 to 16 over 12. If your instinct is to set it up differently, that's fine. The way that you're going to check if yours is also correct, your 16 and your x should be diagonal somehow. Okay? It doesn't matter where they're located, but as long as those two are the ones that are diagonal, then you know you did it right. Okay? All right, so then let's solve this. So 16 times x equals 10 times 12. 16x equals 120. And then divide. So what do we get? 7.5. That sounds right. And if it did not divide nice and clean like that, and it was repeating and all gross, then just keep it as, you would just reduce this fraction down and then keep it as fraction. Yeah.
I still don't understand why you would have to put the 16 and x like across.
So it's just basically how that's just going to end up happening. Your goal isn't to try to get the 16 and the x diagonal. That'll naturally happen if you set it up correctly.
Okay, why do you have to do 10 over x?
You don't. So if you wanted to do x over 10 and then 12 over 16, you could. If you wanted to do like 10 over 16 and then x over 12, if you didn't even want to start with the 10 and you want to start with any of the other ones, you could do that too. Yeah, there's like a bunch of ways that you can set it up
You would
the right
still
way.
get the same answer.
Yeah. Yeah, as long as your diagonals end up being the same, then you know you did it right because it'll naturally happen if you did it right. Okay? Yeah.
What is like the circle and the line?
Oh, I was just showing which one I was starting with. So since I started with the 10 on top the first time, then I wanted to make sure to start with the 16 on top the second time. Yeah, so just make sure you're starting with the same triangle both times, okay? Or same side or whatever it is that you start with. All right, so you guys go through and try to set up this one. So just set it up the way that your instincts would have you set it up, and then you can check to see if you did it, okay? one with a 4 to start with. So just pick one. Cool. So 12 over. Awesome. So then just repeat the same thing. No, so see if you start at the 12. Yeah, so 16 over x. And then just put an equal sign between them. And then 16 over x. And then just follow that with 11. I think so. All right, so let's go with this. So I'm going to set it up the way that I would, and then don't erase yours if it's not the exact same, because you're going to check and see if yours is also correct, okay? So I would probably do x over 18 equals 16 over 12. Now, the way that you can check if yours is also correct, you should have multiplied the x and the 12 together, the diagonals. Okay, so as long as you had 12 and you had x diagonal from each other, that you multiplied those, then you did it correct. Okay, so you do 12 times x equals 18 times 16. So you had 12x equals, I don't know, 2 something, 8s and 4s and 288. Yep, and then divide by 12. So what did you guys get for x? 24? That sounds right. Yep. Okay, any questions on that? Yes. Okay, what did you, how did you have this set up?
I had the x be 16 from the numeric equals 16 times 16 divided by 16. Where the 16 times 16
So on this fraction you had what?
16
16 on top?
Yeah.
So you had 16 over x?
Yeah.
Okay, so you had 16 over x. So then on the other one, so you did this one and then this one, right? So then for the other fraction, you want to copy that same pattern. So what should you have on top on the other one? 12, but so you have 16 with the x, right? 12 and what? That's not 16.
18.
18, yeah. There you go. So does that make sense?
Yeah.
Okay. Okay. Can we move on? Yeah? Okay. So it says, the shadow cast by a tree is 15 feet long. At the same time, a person who is 5 feet tall casts a shadow that is 3 feet long. How tall is the tree? These can seem really intimidating and weird, right? But you're just setting up proportions. You're setting up triangles. I literally have to draw a picture for these. Like, I can't do it with that one, I swear to God. So I'm just going to draw a picture real quick. Okay, so you have a tree.
Oh, we can't.
Oh.
Can't see the thing.
Oh, sorry.
We should see a beautiful drawing.
Okay, so a tree. And then we have a person. And they both have a shadow, right? So basically what this is creating is similar triangles, okay? So we look, see how this is creating a triangle? This is creating a triangle? Yeah? Okay, so then start labeling with the problem. So it says, the shadow cast by a tree is 15 feet long, so you're going to label the shadow of the tree 15. At the same time, a person who is 5 feet tall, so this person's going to label 5, casts a shadow that is 3 feet long, so it's going to be 3. How tall is the tree? So the height of the tree is going to be our x. Okay? And then just set it up the way that makes the most sense to your head, right? So I would probably do x over 5 equals 15 over 3. But however you set it up, just make sure that the 3 and the x ended up as diagonals, and then you're good. So I'll do 3 times x equals 5 times 15. Three x equals what? 75. So then what does x equal? Mm-hmm. 25, and then this is referring to an actual thing. So 25 what? 25 feet, yeah. Okay, yeah.
I did 15 over 5 and then x over 3. So like
So you said 15 over 5.
an x over 3.
So those two would be the only ones that you couldn't pair together. Because so if you look at 15 and 5, one of them is a shadow and the other one's an object, and then they're also on different triangles. So they have nothing in common.
Okay.
Does that make sense? Okay. So like the
you want
15,
the things in common.
yeah. So you like 15 could be paired with 3 because they're both shadows, or 15 could be paired with x because they both have to do with the tree. Like they're both in the same triangle. Okay. All right. So you guys do that last got it one.
Do you want the bigger or smaller number?
That doesn't matter.
Thank you.
Are you ready to go over it? Yes, no, yeah. All right. A man who is 6 feet tall standing next to a building. Okay. All right, so we got a man in a building. The shadow of the man. Okay, hold on. Let me just go through and label this. Okay, so a man who is 6 feet tall. 6 feet tall is standing next to a building. The shadow of the man is 3.5 feet. And the shadow of the building is 17.5 feet. What is the height of the building? Okay. So the way that I would set this up is I would do x over 6 equals 17.5 over 3.5. But as long as your 3.5 is with the diagonal with your x, you're good. Okay. So do 3.5x equals. Geez. I don't know why I did that. I guess we'll just do that. All right, so then you'll have 3.5x equals whatever that is. I don't know. 60 plus 42, 102 plus 3, 105. It is 105? Okay. Okay, and then divide by 3.5. 30? Okay. Do you have any questions on that? That's like a classic SAT one, guys. Keep coming up and coming up and coming up. Okay. We're gonna put up your guys' lesson check. And then you guys have Math Excel when you're done with this too.
You send anything new, or is it just the stuff that we've had?
So if you've had, yeah, so you just know you have 2.8 you can do. Are you guys ready for answers or not yet? Huh?
No.
Not yet? Okay.
didn't collect these today.
No, I'm just because remember this math Excel, your homework's not in there anymore. So those can just go home and just be thrown in a drawer for like when finals time comes. Yeah, good. Are you guys ready for answers yet? Or not yet? Yeah. Yes, no? Not yet? Okay. Where's your Chromebook? Golf. Golf there, you need your Chromebook? You work on homework?
I'm not done with work.
You're all done with it? I highlight that.
I can show you.
Okay, sure.
Hold on, ready? Hold on.
Alright, I'm gonna put answers up. Don't look if you don't want to see it, okay? Just so we can shut it all down and ask questions if we have them.
Question. So I think I confused myself. This last problem over here.
Mhm.
What you did was you put this triangle. Oh, I did confuse myself. Sorry.
Are you sure? You good?
Yeah.
Okay.
Alright, listen.
Sorry, I'm tired.
Doesn't.
All of them are above 80.
Get him to 100, Gavin.
Nice.